So we're sticking in 6.1 today, and we'll be there a couple more days. The topic that we're going to talk about first is coterminal angles, which in the warm-up there, as I told you, we found a bunch of coterminal angles, right? Coterminal, if you were kind of break this down, what does the word like co mean? What do you think of someone said? Okay, like co-ownership, like two people, together, yeah. So like two people together, co-owners or cooperative. That means you work together, right? Operate together. Yeah. So I think like together is. And then what does terminal mean? As Trevor eloquently stated yesterday.
Listen, okay. I knew terminus uses. I was like, is it similar?
Yeah, it's the same. Yeah. So it ends, right? Yeah. So coterminal angles basically end together. They end at the same spot. That means coterminal angle. And then we're also going to talk about radian conversions as well. So to convert from degrees to radians and vice versa. So let's go ahead and just do a brief definition of a coterminal angle. Kind of like the name implies, their angles have the same terminal side. Okay? Terminal side is something we labeled yesterday when they're written in standard position. So they have the same terminal side. They end together. Terminal side is the same when they're written in standard position. So we're going to make an example here. So let's see a few coterminal angles. Let's say this one is about 130 degrees from here. So it'll be standard. What's that? 130. So here's 90.
Yeah, no.
So let's say that's 130. So what would be a coterminal angle going in the negative direction? Yeah. Huh? Yeah. So negative 230 would be the exact same angle. Just going around the other way. It has the same terminal side, so we would draw it exactly the same way. Okay, another example. If I start here, I go all the way around the circle, and then I end there. What would that green one be? Huh? What did you say? 490. Yeah.
That's what I said.
Yeah. Sorry, I didn't hear you well. Yeah, 490. 130 plus 360, because 360 is all the way around. And let's go ahead and do one more. What if we go around backwards? So this way, make it more confusing there. Huh? Negative 590? Yeah, that'd be correct. So this way around would be negative 360 is one way around, and then you got to go negative 230. So negative 5. So how are we coming up with these? Well, pretty simple. Let's try an example. What we're often asked to do, one thing would be just find some coterminal angles. Okay. So let's just say, let's find 3 coterminal angles to 190 degrees. Okay. So a couple ways you can do that. And you can add 360 to it, right? So 190 plus 360. What's that equal? 550 degrees. So that's a coterminal angle. You could add 360 again, get another bigger one. You could also subtract 360 to get a coterminal angle. What is that equal? Negative 170. All right. So those are some examples of coterminal angles. Often what we're asked to do though, and you're going to do some problems like this on delta math, is we're given an angle. Let's say we're going to find the coterminal angle to, let's say, 800 degrees. That is between 0 to 360. So an angle like 800 degrees doesn't mean a lot to us just because it's a lot bigger than angles that we know. But we could sort of like put this in simpler form by finding the coterminal angle that's between 0 and 360. How would we do that? Yeah, we just subtract multiples of 360. So we do 800 minus 360. And we see if it's between 0 to 360. That's going to be 440 degrees. So that's not good enough yet because it's not between 0 to 360. So we just do it again. And we do that again. And we get 80 degrees. So then we could actually just graph 80 degrees. That would be right here, right? 80 degrees. And that would be the same thing as 300 or as 800. Actually, you don't have to actually do this, but so we wanted to plot 800 degrees. Well, it's the same as 80 degrees, so we would plot 80 degrees. And we know we went around the circle once, twice. So it'd be around once, around twice, and then end there. So that would be standard form of 800 degrees. So this is typically what we're going to be asked to do is find a coterminal angle between 0 and 360. We could also do this for the negative. If it was the same question and we said negative, let's say 450 degrees, how would we find the coterminal angle there? Just add 360, right? Put up there. So you're just going to add 360. That's negative 90. Well, that's not what we're looking for because it's not between 0 and 360. So we just add it again. Plus 360 again. So that's going to be your first section you're going to do on Delta Math. They have a lot of good questions for this section. So that's going to be your first one, is finding coterminal angles. Flip back in just a sec. So for example here, negative 419 degrees. That's what it says. The angle, this is just theta. What's the angle? Angle is negative 419 degrees. We want to find it between 0 and 360, find the coterminal angle. So all we do is negative 419 plus 360. Figure out what that equals, just use a calculator, that's negative 59. And then it's still not between 0 and 360, so we just do it again. And then 301 degrees. And that's all we're going to have, 301. It already has the degrees. So that's your first section. Those are all coterminal angles. Right? This is the easy part. Where it gets a little more challenging is if we want to change units. So these are going to be two important formulas here. Make sure you write down these two formulas. So if you think of like another example of these changing between different types of measuring, the way that we measure temperature in the United States is in Fahrenheit, right? 70 degrees Fahrenheit is more meaningful to you than 20 degrees Celsius, right? You wouldn't know what 20 degrees Celsius is. But most of the world actually uses Celsius. Yeah, it makes a lot more sense than Fahrenheit does, but whether we measure feet and inches doesn't really make sense. If you actually use meters and centimeters, it actually makes way more sense. But America is just different, so we have our own ways of measuring things. But there's a conversion formula to go from like Fahrenheit and Celsius. Does anybody ever use that in like chemistry? From Fahrenheit to Celsius? Yeah, it's like I don't remember exactly, but it's like 5 nights times the Fahrenheit minus 32, I think, and then the opposite is true. I think it's like 9/5 the Celsius plus 32. So it's either 9/5 or 5 nights to go back and forth with 32. So it's something like that. So we have a similar formula to go from degrees to radians and vice versa. So again, this is something that you could use like in chemistry. There's also Kelvin as well as another way you measure temperature. Huh? Yeah, Kelvin. Yeah. So lots of different ways. We have the same way of doing angle conversions. And actually, the more you use math, so the higher you go up and you do pre-calculus or if you haven't do calculus, the more you do math, degrees are less and less common. You pretty much only use radians the higher you get. So that's the unit that we're going to be talking about. And is actually the more common unit in math is radians. Despite what you've been taught your whole life, degrees actually aren't all that common. It's common in our country, but in most countries it's not the case. So to go from degrees to radians, a very simple formula, we're just going to multiply by pi over 180. We're going to multiply by pi over 180, and then we just simplify it. When we do this also, we're actually just going to leave pi as pi. So we'll go here. We're going to leave in terms of pi. I'll explain to you what that means. We're going to always leave our answer in terms of pi. So I told you in the warm-up that 180 degrees, a coterminal angle, or just another way of saying that angle, would be pi. Pi is equivalent to 180 degrees. Same with 3 pi. And I'll show you how this works here. So let's start with that example that I gave in the warm-up, which is 180 degrees. And we want to convert that to radians. So all we do is take the degrees there, and we're going to multiply by pi over 180. And when you write it, think of it as a fraction. Think of this as just like 180 over 1. Well, pi over 180. We're not going to do this. We're not going to go 180 times pi and get a decimal, 565 point whatever, and then divide by 180. We're not going to do that. All we're going to do is just write it like this. 180 pi over 180. Just multiply straight across. In this case, it's very easy because the 180s cancel. It's just 1. Okay? This is actually just pi. Pi grams. 180 degrees is pi. Previously in your math life, you've probably just seen pi like in the area formula of a circle, right? Pi r squared, or like circumference 2 pi r, things like that. But pi is actually used a lot in measurement. Let's try another one. Let's try 45 degrees. We're going to convert that to radians. So we're going to multiply times pi over 180. And again, we're not going to type this into our calculator. We're not going to do 45 pi divided by 180. You can use your calculator. I'll show you how to do that. But we're not going to touch the pi. We're going to leave pi just as pi. So this is our answer, but we're not going to leave it like this either. We're not going to leave it as 45 over 180 because you can simplify that a lot. We need to write it in simplest form. So one option would be to just do it by hand if you want. Divide both of these by 5 and just continue to reduce it as much as you can. On your calculator note, you're probably going to want to do it this way. I'm okay if you use your calculator for this. But you're just going to do 45 divided by 180. Easiest around these calculators. And you'll get a decimal. This is 0.25. And then you're gonna hit math and then frac. I've showed you this before. It's like math, and then there's an arrow that says frac. That's what you're gonna do. Click on that. Enter again, and you get 1/4. So this is 1/4. What we're gonna write that as pi over 4. Pi over 4. That's equivalent to 45 degrees. It's pi over 4. Because it's 1/4. So this introduces to 1/4. So we say 1/4 pi or pi over 4. Practice a few more of these. Let's do one more here. Let's say 270 degrees. So we're going to convert that to radians. So same formula. Times pi over 180. So just think of this as one big fraction. 270 pi over 180. And then if you have a calculator, go ahead and try it. If you don't, it's fine. You can go with one. But you might be able to reduce this without a calculator. Ideally, that would be the case. You can actually cancel the zeros, and then 9 goes in the both one, so it would be 3 over 2. But if you can't do that, okay. Do 270 divided by 180, enter, and then you do math, frac, enter, and you get 3 over 2. So this is 3 pi over 2. If you gave this as the answer, that would be wrong. It has to be in simplest form. So that's how we go from degrees to radians. Your assignment on this is very similar to what we just did. Show you here quick. We're not done yet though, so don't start working on it yet. Same thing, angle from degrees to radians. This one happens to be a bigger one, so if you wanted to write down this example, you could. So this example is 720 degrees. So we're going to convert this to radians. It's going to do times pi over 180. That is going to be 720 pi over 180. Yeah, well actually, so yeah, it'll just be 4 pi. You can do it on your calculator if you want to. 720 divided by 180. And you actually just get 4, so you don't even need to reduce it. It's 4 pi. So that's what we type in. It has the pi symbol for you. You're just going to type 4 and then pi. So generally that's the easier, but neither of them are hard. But radians to degrees to radians, there you go. The last thing we need to cover is radians to degrees. So how do you go the opposite way? So let's go the opposite. Radians to degrees, you're going to just do the inverse of that. So we're going to multiply by 180 over pi, and then simplify. When you're talking about degrees, though, our simplification is a little different. We don't have to worry about fractions, because you would never say like 300 and 2/3 degrees. It would actually be a decimal. So decimals are actually okay. On the Delta math problems, it actually kind of tells you when it's going to be a decimal because it tells you to round to the nearest tenth. You won't always have a decimal, but you can get a decimal. Just the inverse. Then multiply by pi over 180 or 180 over pi. So let's try one. A common angle is 3 pi over 2. Common angle that we use. When we do the unit circle, a lot of these you'll memorize how this converts to degrees. So what we're going to do is times by pi over 180. So times Sorry, 180 over pi. Or 180 over pi. And what normally happens is, notice we have a pi on the top and the bottom. So those are just going to cancel each other. You don't even have to type that in. If there's a pi on the top and the bottom, they cancel, which will be the case most of the time. So then it's just going to be 3 times 180, and then divided by 2. And you can just type that into your calculator. 3 times 180 divided by 2, and you get 270. So it's equivalent to 273. So there's only 2 formulas. You multiply by pi over 180, or you multiply by 180 over pi. Let's try another one. I'll just say, let's make one up here. Let's say it's 7 pi over 8. Same process. Multiply by 180 over pi. I would suggest writing it out, even if you got the hang of it. Just write it out every time. You can see these cancel. So we're just going to do 7 times 180, and then divide by 8. And here we take a decimal. That's okay. 157.5. Generally, you want to round to the nearest 10. So that's how you can tell from that. It's 157.5. That's fine to have a decimal. There's just one type of problem that's slightly different. A couple of them you'll see. These aren't really that useful, but they are in the math problem set. Is if we have something like 3 radians. This is that. Radians are generally written in terms of pi, but occasionally they won't be. So if we have something like 3 radians, we're still going to do the same thing. We're just going to do 3 times 180 out of pi. Except we're going to actually have to type pi into our calculator for that one. So we're just going to do 3 times 180 and then divide it by pi. The pi on the calculator is a little up arrow there, and you can see it in blue, the little pi symbol. So make sure you use the symbol 171.88, so we'll say 171.9. So that's it. We're either multiplying by pi over 180, 180 over pi, and simplifying. So you've got the remainder of the class period to work and ask me for help if you're confused. On the assignment, you'll see these 3 coterminal angles, degrees to radians, radians to degrees. There's also 2 timed ones. These I want you to do if you finish the other ones. You don't have to do these last 2, but they're just timed ones to see how fast you can do it. So these first 3 are required. A lot of you will get these done, and then I do want you to do those timed ones if you get them done. But those 3 are required. So work on those. Ask me for help, ask the neighbor for help. You would need a calculator definitely to do those. So, go ahead.